Hi all, welcome to Go Classes. So let's start the discussion of today's DPP. Before we start, please let me know audio, video, volume. Is everything clear? Is everything fine? Please let me know audio, video, volume, echo. Is everything perfect? Okay. So let's start now. Hi all, welcome to Go Classes YouTube DPP series for Gate CS, Gate DA, GOT DPP series. Today's DPP is subject Discrete Mathematics, topic Combinatorics. All the questions are based on counting poker hands. What is poker? Poker is basically cards game. And what is a poker hand? There are different type of poker hands. Hand poker hand simply means this is a five card hand, or I can say it is a set of five cards. And there are different type of poker hands. So in the gate exam, they will define the specific type of poker hand they will define, and then they will ask you to count the number of that specific type of poker hand. Okay. So in this session, we are going to discuss all the different type of poker hands that are there. There are 10 total 10 different type of poker hands are there. We will discuss all of them, and we will see their definition, understand the definition, and then we will count the number of all the specific type of poker hands. Okay. So let's start. Let me tell you that GOT DPP series means Go Classes YouTube DPP series for Gate CS, Gate DA. The complete playlist link you can find in the description, also in the pinned comment. All the questions in our YouTube DPP series are taken from standard resources to ensure that you practice top quality questions. All the questions will be within the GATE syllabus, and the difficulty level will be within the GATE difficulty level. You can see on YouTube, you can search GATE CS DPP Go Classes. You can put this in the YouTube search box, and this Go Classes GOT DPP series, this complete playlist will show to you. Okay, so you can check it out. This complete playlist, you check it out. You can see on YouTube, if you search GATE CS DPP Go Classes, then all these videos of Go Classes that will show to you, these DPP videos that will show to you, in these you can see that in the description you can find the playlist link. Okay, you can see GATE CS GOT DPP series, the complete playlist link you can find in the description, so check it out. A very important announcement for all the GATE DA aspirants, that for GATE DA also we have started GOT DPP series, basically YouTube DPP series we have started for GATE DA also on our GATE DA YouTube channel. You can see Go Classes has YouTube channel for GATE DA, also Go Classes has YouTube channel for GATE CS. Okay, so visit Go Classes GATE DA YouTube channel, and there we have started the YouTube DPP series for GATE DA aspirants also. So you check it out. You can see machine learning DPP MCQ practice questions for GATE DA aspirants. Okay, so do check it out, and you can see this playlist link also you can find. So visit the Go Classes GATE DA YouTube channel, subscribe to it, and then don't miss any YouTube DPP for GATE DA. You can see GATE DA GOT DPP series playlist link. The playlist link also you can find in the description. Now, so let's start now. Just give me just 2 minutes. I think wrong slides I have loaded. Okay, so please just give me 2 minutes. Let me load the correct slides. Okay, just give me 2 minutes. Hi all. So welcome back. Actually, by mistake, I had loaded some wrong slides, I can say, and now I have correctly loaded the slides. Okay. So let's resume now. Audio, video, volume, echo, everything is fine. Let me know. The slides, everything is fine now. Okay. So let's resume. Now we are going to discuss counting poker hand. These questions, these type of questions. Let's discuss. But before that, let's know about the cards. The standard deck of 52 cards. Let's know about it. Most of you already know about it, but let's revise it quickly. So you can see in the standard deck of 52 cards, total we have 52 unique, 52 different cards we have. Ignore the joker and those cards. Okay, the 52 cards we have in the standard deck of 52 cards, and these 52 cards are divided into four types or four suits, and for every suit there are 13 cards. Basically, on every card, you have a value and a suit. Every card is made of two things. There is a value and there is a suit. You can see, let me show you. These are the 52 cards on your screen. And if you notice, you can see that every card has two components, a value and a suit. Okay, here you can see that this is a suit. Okay, for example, if you see the value 2 cards, there are total 4 value 2 cards. And these 4 are the suits. I told you that there are 4 suits or 4 types. The 52 cards, they are divided into 4 types or 4 suits, and for every suit there are 13 cards or 13 values. Okay, for every suit there are 13 values, and for every value there are 4 suits. You can understand like this. And total how many cards we have? 13 into 4, that is 52. So for every suit there are 13 values. For every value there are 4 suits. Okay, simple. Here you can see, for every value there are 4 suits, and for every suit there are 13 values. You can see these are the values: 2, 3, 4, and so on. 10, jack, queen, king, ace. You can see these are the values. Okay, so for every suit there are total 13 values, and for every value there are 4 suits. These are the suits. You can see heart, this is called heart, this suit is called heart, this is called diamond, this is called club, and this is called spades. So for every value there are 4 suits, and for every suit there are 13 values. These values, these 2, 3, 4, and so on, jack, queen, king, ace, these values, these are also called rank. These are also called rank, these are also called denomination. So you can see the card value, that is also called rank, that is also called denomination. Okay, so I can say that for every suit there are 13 values, or I can say for every suit there are 13 ranks, or I can say for every suit there are 13 denomination. I hope you understood. Okay, and let me tell you, these values, they have order. So by default, this is the order of the values. Means by default, this ace is considered as the highest rank or highest value or highest denomination. Okay, remember, there are some card games in the poker also, there are some games where ace is considered as the lowest value, and there are in most of the games ace is considered as the highest value. By default, in combinatorics, in probability, by default we are going to assume that this ace has the highest rank or highest denomination or highest value. So you can see this is the order of values: 2, 3, 4, and so on. 9, 10, jack, queen, king, ace. Okay, I hope you understood. And every card has total 2 components, a value and the suit. For every suit there are 13 values, for every value there are 4 suits. I hope it is clear. Now you can see here that the standard deck of playing cards has 52 different or 52 unique cards. They are divided into 4 suits. The suits are heart, diamond, club, spades. And every suit has 13 cards. What are the 13 cards? You can see ace is there. The numbers 2 to 10 are there. And the face cards, jack, queen, king. Let me tell you an important point, that by default, ace is not a face card. So if they mention face card, then by default, jack, queen, king, these are the face cards. The remaining are not the face cards. And by default, ace is not a face card. Okay. So here you can see that the face cards, these are jack, queen, king. These are called face cards. Okay, simple. Now you can notice one thing, that the heart and diamond, these suits, they are red color, and the club and spades, they are of black color. Okay, so you can see The heart and diamond, these two suits, they are of red color. Club and spades, these two suits, they are of black color. So I can say there are 26 black cards and 26 red cards. Okay, so you can see 26 black cards, 26 red cards are there. These 26 red cards, these are also I can say divided into two suits, diamond, heart. And remember, every suit has 13 cards or 13 values. These are the values you can see, and this is the decreasing order of values. Means ace has the highest rank, highest value, and then this is the decreasing order. Okay, and these are the face cards, king, queen, jack, these are the face cards. By default, ace is not a face card. Okay, so you can see every card has two components. There is a rank, or I can say value or denomination, and there is the suit. So for example, look at this card. This is 10 of spades. Okay, because the value is 10 and the suit is spades, so I can say this is called 10 of spades. Simple. Now let's see a note about the ace card. In in some card games, ace is considered as the lowest rank, and in most of the card games, ace is considered as the highest rank. Let me tell you that by default we will consider ace as the highest rank, unless the problem, the question explicitly states something else. Okay, so in the question, if they give you the information about the ace card, then you can consider that. Otherwise, by default, we will consider ace as the highest value card. And remember, in most of the questions, in majority of the questions, the order is irrelevant. It does not matter what is the order of the values. The order of card values, that is irrelevant. That does not matter in most of the questions. But if there is a question, you can see, if there is a question which involves, in which the ordering matters, then you can see the information will be given to you for the ace card. If no information is given, then you can consider ace as the highest card. Okay, so the by default order, that will be, this is the decreasing order. You can see ace has the by default highest rank, and then you can see this is the decreasing order: ace, king, queen, jack, and so on. Okay, simple. You can read this. You can see that this is the by default order from high to low. Okay, ace, king, queen, and so on. So you can see this is the by default order from high rank to low rank, or high value to low value. Let's see a note about the ace card. So one note, we have already seen that by default the ace value, the ace card that has highest rank. But the question can give you something else, then we have to consider that and we have to solve according to that. Okay, and you can see by default ace is not a face card. Okay, now let's start the discussion of counting poker hands. I told you there are total 10 questions possible. There are total 10 different type of poker hands. 10 specific different type of poker hands are there, and we need to count the specific number of poker hands. Okay, all the 10 specific type of poker hands, basically we need to count total number of them. I hope it is clear. So let's start now. Let's solve question number 1. Counting total number of 5 card hands. In the poker game, hand means total 5 cards. Okay, a set of 5 cards. When I say set of 5 cards, then remember, order does not matter. How you arrange them, that does not matter. Only those 5 cards matter. You can see in the poker hand, remember, whatever poker hand you have, in the poker hand, the order of cards does not matter. Okay, if I give you 5 cards out of 52, if I give you 5 cards, then the arrangement of those 5 cards does not matter. Okay, only it matters what are those 5 cards. Okay, so basically in the poker game, the hand, this is a set of cards. Remember, this is not a arrangement of cards, this is a set of cards, so order does not matter. Now the question number 1 is that how many different 5 card hands are possible from the standard deck of cards. And you can see that only it matters what are those five cards. It does not matter how they are arranged, how they are ordered. Very simple. So what will be the answer? Total we have 52 cards. From those 52 cards, we need to choose 5 cards. So this is a combination problem because the order does not matter, the arrangement does not matter. Total we have 52. We have set of 52 cards, and from them we want a set of 5 cards. We want to choose total 5 cards. Okay, so very simple point, that we have total 52 different cards. We have 52 different cards we have total, And from these cards, we want to choose, we want to select, or we want to choose 5 different cards. Okay. So how many ways are there? That's 52 C5. Very simple. Okay. 52, choose 5. This C simply means choose. I can say 52, choose 5. Okay. Or I can say 52 C5. So basically, this 52 C5, this is your answer, because remember, this problem, this is just a combination problem. This is not a permutation problem, because the arrangement does not matter. If I give you 5 cards out of 52 cards, then for those 5 cards, the arrangement does not matter. It matters what are those 5 cards, only that matters. Basically, this is a combination problem. This is not arrangement or permutation problem. So the answer will be 52 C5, and I can open it. And what this will become? What is NCR? That is n factorial divided by r factorial, n minus r factorial. So you can see 5 factorial, 52 minus 5, that is 47 factorial. So this will be the answer. Okay, very simple. So this is the first question. I hope you understood. If you calculate this value, you are going to get this value. So very simple question. I hope you understood. Ankush is asking, sir, you came live yesterday for Discrete Mathematics DPP, that is not uploaded. Ankush, actually, there was some issue, and that session I am taking today again live. This session that I am taking, this session I took yesterday also, but there was some issue. So I made that video private. That video is private, and the complete yesterday's video I am taking again. Okay, so basically, what we are discussing, the questions that we are discussing today, these same questions, only 3 or 4 out of these questions I discussed yesterday also, but all those questions I am discussing again today. Okay, so don't worry, that video I have removed. Okay, there was some issue, and now all the questions I am discussing again. Okay, so please do not worry about it. These same questions I was discussing yesterday, but there was some issue, so I could not discuss. Okay, so that is the reason we are discussing all these same questions again today. Okay, I hope it is clear. So let's start now. Let's solve this question. Counting one pair poker hand. Now the definition is given to you. You read the definition, understand the definition, and then solve the question. Remember one thing, that in the gate exam, they will not ask you to count the one pair poker hand. They will give you the definition. You don't have to remember the definition. You don't have to remember what is the definition of one pair poker hand, what is the definition of royal flush, what is the definition of flush. These things you do not have to remember. In the gate exam, they will give you the complete definition. You just have to read the definition and solve the question. Okay, so you can see we are counting the one pair poker hands, and the complete definition with example is given to you. You just have to understand and solve. Okay, so let's see what is this question. What is one pair poker hand? Let's understand the definition. The lowest hand that is worth anything in the most poker games, that is a hand with exactly one pair. You can see with exactly one pair of cards of same denomination, means basically one pair means two cards. So two cards of the same value. Okay, two cards of the same value, for example value 8. So two cards of the value 8, and then the remaining 3 cards, they will have distinct denomination, distinct values. So you can see there should be no second pair, means we should have only one pair. We should not have any second pair. We must have exactly one pair. So you can see the remaining 3 cards, they must have distinct values or distinct rank or distinct denomination. And you can see that those remaining 3 cards, they will have value different from the value of this one pair. Okay, so you can see we have exactly one pair, means we have 2 cards of the same value. For example, let's assume value 8. For this value 8, we have 2 cards. Okay, and the remaining 3 cards, they have distinct values. And also remember, the remaining 3 cards, they have value different from the value of this pair. For example, if the value of pair is 8, then the remaining 3 cards, they will have value different from 8. And also those 3 cards will have distinct values. So the point, I hope you are understanding, that we must have exactly one pair. We should not have any second pair. Also, we should not have three of a kind, means we should not have 3 cards of the same value. We must have 2 cards of the same value, and we should not have more than one pair, and we should not have three cards of the same value. I hope it is clear. One example is given to you. You can see for this value 5, we have two cards. So you can see this is called pair. So now we have one pair. Now remember, the remaining three cards, they have different values and their value is different from the value of this pair. Okay, so you can see in this example, we have exactly one pair. We do not have two pair, we do not have second pair, and we do not have three cards of the same value. Okay, we do not have more than two cards of the same value. I hope it is clear. So the definition is very clear. The example is also given to you. So you can see one pair. It means we are having two cards of the same rank, two cards of the same value, and there are three other cards that have three different ranks or different values. So once you understood this, now you can solve this question very easily. So let's solve it. You can see we want one pair. So total how many one pairs are possible? For one pair, what we need to do? We need to choose one of the value for which we will have two cards. Do you agree with me? Okay. So you can see these are the values. If you look at the card values, then these are the card values 2, 3, 4, 5, and so on. King, ace. These are the card values, correct? So total 13 card values are there for every suit. For any suit, there are 13 card values. Now you can see we want one pair. One pair means two cards of the same value. So first we need to decide which value will have two cards, correct? Okay. So you can see there are total 13 values. 13 values are there. From them you choose one value. And for that value, we will have two cards. Okay. So you can see here we are choosing the value, we are choosing the card value for pair, for the pair. Okay, means we are choosing for which value there will be a pair, for which value there will be two cards of that value. Okay, so you can see from 13 values we are choosing one value for which we will have the pair. So you can see this is the value, this is the card value, or I can say this is the value for the pair. Now you can see once we have chosen a value, let's assume we have chosen this value king. Then you can see for this king I need two cards because I want pair, right? I want two cards of the same value. So you can see once we have chosen the value for the pair, then for that value I need two cards. But you can see for any value there are total four cards, four suits. For any particular value there are total four cards in four suits, right? Yeah, right. So you can see once you have chosen the value for the pair, then for that value I need two cards. So for that value total we have four cards, so I need to choose only two cards. So now you can see that now this pair you have chosen. Okay, so you can see now this is the pair, this is the one pair, I can say. This is the one pair that we wanted. Okay, now remember, now we need three more cards, correct? But they must have different rank or different values, and their value must be different from this value also. Okay, so remember now we want total three values we want, and three different values we want, remember, because we want three more cards of different values, and their value must be different from this value of also this value which we have chosen for the pair. From this value also those three values must be different. So you can see once this value has been chosen for the pair, then total how many values are remaining total 12 values are remaining. From these 12 values, three values I need to choose because I want three cards of distinct values, different values. So you can see now you can see this value I have chosen for the pair. So remaining how many values are there? 12 values are there. From these 12 values, choose three different values. Okay, so you can see 12C3. This we are doing for the remaining three cards values. Okay, so you can see these are the values for remaining three cards, remaining three cards. Okay, now let's assume for a moment, let's assume that these are the three values that you have chosen for the remaining three cards. Means you have chosen the value 2, value 3, value 4. These three values you have chosen for the remaining three cards. Then you can see for each value there are four cards, but I just want one card for each value. Yes or no? Okay, remember these three values I have chosen. for the remaining three cards. And you can see for each value there are actually four cards. For example, for this value 2, there are total four cards, but I just want one of them. I want only one card of value 2. Similarly, there are four cards of value 3, but I only want one of them. So I want only one card of value 3. I want only one card of value 4. Okay, so you can see for this value 4 also there are total four cards. I want only one of them. I hope it is clear. So that's it. This is the answer. So your final answer will be this whole value you can calculate means 13C1, that is 13 into 4C2 into 12C3 into 4 power 3. Okay, you can calculate, this will be the answer. I hope you understood. Okay, so this is quite easy. You just think about it, because we want only one pair. We don't want more than one pair. We don't want more than two cards of the same value. Okay, so you can see we want exactly one pair. So first we will choose a value for which we will have the pair. So from 13 values you choose one value, and for that value I want the pair, means for that value there are total four cards, I want two of them. Then you can see I want three more cards of distinct values, but those three cards values must be different from this value of the pair. So you can see once you have chosen this value for the pair, then total 12 values are remaining. From those 12 values I can choose three values for the remaining three cards. Once I've chosen three values, then for each value there are four cards available, but for each value I just want one card. So that is the reason you can see for each value you can see there are four choices. Okay, for each value four cards are there, I want one of them. Okay, so this will be 4C1 into 4C1 into 4C1. I hope you understood. So this is the complete conclusion of this one pair card hand. Okay, I hope it is clear. You can read the complete explanation here. Whatever we have seen, that is written here. Okay, so you can see 13, that is 13C1 into 4C2 into 12C3 into 4 power 3. So this is the answer. And if you want, you can find the probability also. How to find the probability of one pair? The probability of getting one pair, that is the total number of one pair hands possible divided by the total number of five card hands possible. Yes or no? This is the total number of five card hands, 52C5, because there are total 52 cards. Out of them we can choose any five cards. So 52C5, this is the total number of five card hands. And you can see this is the number of one pair card hands, one pair poker hands. So what is the probability of getting one pair poker hand? That will be the total number of one pair poker hands divided by the total number of five card hands. Okay, so you can just calculate, the probability will be approximately 0.4226. Okay, you can just read this explanation here. Okay, you can read the explanation here also. Multiple explanations I have provided to you, and the explanation also we have seen. The complete detailed explanation also I have provided. Okay, here you can notice one very interesting thing, that if you see the probability of getting one pair poker hand, then that is approximately 0.4225, something like that. Okay, so if you see this probability, what it actually means, this means that what are the odds that you will get one pair poker hand if you are playing the poker game. From 52 cards, if I give you 5 cards, then what are the odds, what are the chances that you will get one pair poker hand? Then let me tell you the odds or the chances of getting one pair poker hand, that is 2 in 5. Okay, these are the odds or these are the chances approximately. Okay, this means approximately that out of 5 times, 2 times you will get one pair poker hand. Okay, so these are very good chances, right? These are very good odds, I can say. And let me tell you, if the odds are good, if the chances are good, then that card hand, that poker hand has lowest value. Okay, do you agree with me? Let's assume that you are playing the poker game. Okay, and you can see getting, if I give you 5 cards out of 52, if I give you 5 cards, then what are the odds, what are the chances that you will get one pair poker hand? Then those odds, those chances are very good, approximately 2 out of 5. So those are very good chances, right? And if the chances are good, if the odds are good, then the value, or I can say the worth of that poker hand, that is the minimum. Okay, I hope you are getting the point. Okay, because out of 5 times, 2 times you might get, this one pair poker hand. Okay, so that is the reason the worth of this one pair poker hand, that is the minimum. I hope you understood this. We will see for the remaining, we will see many more different type of poker hands. We will see what are their odds. Okay, what is their probability? If I give you 5 cards out of 52 cards, then what are the probability of different type of poker hands? What are the odds? What are the chances? And what is their worth? If the probability is less, then the worth is more. If the probability is more, the worth is less. It's very simple. Okay, so let's move on now. I hope this is clear. Now let's see the next question. This question was clear, let me know. Let's solve question 3. Counting royal flush poker hands. The definition of royal flush poker hand is given to you. You read the definition, understand the definition, and solve the question. You don't have to remember the definition of royal flush in the gate exam or in any good exam. If they ask you to count the number of royal flush poker hands, then they will give you the complete definition, and then you have to solve the question. Okay, so let's read the definition. The most valuable hand in many versions of poker, that is called royal flushes. What is a royal flush? What is the definition? Let's read the definition. These are 5 card hands consisting of these values: 10, Jack, Queen, King, Ace, all in same suit. Means total 5 cards, all in the same suit, and these 5 values must be present. Basically, these 5 cards, they must be having these 5 values: 10, Jack, Queen, King, Ace. These 5 values must be present and all must be in the same suit. How many different royal flushes are there? One example of royal flush is given here. You can see all the 5 cards in the same suit. The suit is club. You can see this club, this is the suit. So all the 5 cards in the same suit. And you can see these values are present. These 5 cards, they must be having these values, these ranks. You can see 10, Jack, Queen, King, Ace. All these 5 values must be present. So total how many royal flushes will be there? Let's see. You can see these are the total 52 cards in the standard deck of 52 cards, correct? Now let's see what is the royal flush here. You can see royal flush means 5 cards of the same suit, and those 5 cards, they must have these values: 10, Jack, Queen, King, Ace. So you can see 5 cards in the same suit. So if I consider the suit heart, okay, let's consider this heart. Now in the heart, 5 cards I need to choose, but they must have these values: 10, Jack, Queen, King, Ace. So you can see this is the only royal flush if I consider the heart. Yes or no? For the heart suit, this is the only royal flush that is possible, because royal flush means 5 cards in the same suit, and these 5 values must be there: 10, Jack, Queen, King, Ace. So you can see if I consider a particular suit, then there is only one royal flush. Now you can see if I consider this diamond suit, then you can see in the diamond suit, this is the only royal flush that is there. Yes or no? In the diamond suit. And you can see in the club, in the club suit, you can see that this is the only royal flush. Okay, now let's see spades. When you come to spades, then this is the only royal flush that is there. Because what is a royal flush? This is a set of 5 cards all in the same suit, and these 5 cards, they must be having these values: 10, Jack, Queen, King, Ace. Okay, very simple. So you can see that for any particular suit, there is only one royal flush. Total we have 4 suits. So total we have 4 royal flush only. The number of royal flushes, that is only 4. I hope you understood. Okay, so you can see 5 cards all in the same suit, and the 5 cards must have these values: 10, Jack, Queen, King, Ace. So you can see once you fix the suit, then there is only one royal flush. Total we have 4 suits, so there are total 4 royal flush. So total number of royal flush, that will be 4. I hope it is clear. The explanation is written here. You can easily see. You can see the royal flush hand must consist these values: 10, Jack, Queen, King, Ace, all in the same suit. Since the values are fixed, you can see, because these 5 values are fixed, then you can see that For every suit, there is only one way. Total we have four suits, so there are total four ways, or I can say total number of royal flushes, that is four. So what is the probability of getting a royal flush? That is 4 divided by 52c5. This is the probability of getting a royal flush. This is the probability of getting a royal flush. Okay. I hope it is clear. What is a RF? RF means royal flush. So remember, the probability or the chances or the odds of getting royal flush, that is 4 out of 52c5. 52c5. Why 52c5? Because this is the total number of 5 card hands. So you can see 4, this is the total number of royal flushes divided by the total number of 5 card hands. That will be the probability of getting a royal flush. Okay, and the probability of getting a royal flush, that is very less. You can see 0.00001539. So the odds of getting royal flush, that is very less. You can see these are the odds. The odds or the chances of getting a royal flush, that is almost once in 6,49,740. In Hindi movies, okay, also देर इज अ डायलॉग कि मेरा बेटा तो लाखों में एक है. तो रॉयल फ्लश जो है वो ऑलमोस्ट 6.5 लाख में एक है. द ऑड्स ऑफ गेटिंग रॉयल फ्लश, द चांसेस, द प्रोबेबिलिटी ऑफ गेटिंग अ रॉयल फ्लश, दैट इज once in almost 6.5 lakhs. Okay, so tell me, who has more worth? If you go to the poker game, if you are playing the poker game, royal flush or the one pair poker hand, we have already seen the odds, the probability of one pair poker hand, that was almost twice in 5, 2 out of 5 almost. And you can see the odds of getting a royal flush, that is once in 6.5 lakhs almost. Okay, and let me tell you, among all the different type of poker hands, there are many different type of poker hands. We will discuss in this session all of them. And among all of them, this royal flush has the highest worth because this has the lowest odds, lowest probability of getting. So this royal flush has the highest odds, the highest worth. The royal flush has the highest worth and lowest odds. Okay, so let's move on. I hope you understood this. Let's solve question number 4. Counting straight flush poker hands. Now, what is this straight flush poker hand? The definition is given to you. The complete definition is given to you with example. You read the definition, understand the definition, and then solve the question. A straight flush. This is a hand that has 5 cards, basically a 5 card hand, all in the same suit. All the 5 cards in the same suit and in consecutive denomination. Consecutive values means 5 cards all in the same suit and consecutive values, consecutive rank, consecutive denomination. But it should not be a royal flush. In the royal flush also we have all 5 cards in the same suit and consecutive denomination. Correct? In the royal flush, if you remember, the royal flush is basically in the 5 cards in the same suit and the values are 10, jack, queen, king, ace. So basically they are also having consecutive denomination and all the 5 cards have the same suit. That is royal flush that we have already seen in the previous question. You can check it out. The number of royal flush we have already counted in this session. Now you can see what is a straight flush. This is a 5 card hand, all the 5 cards in the same suit, consecutive denomination, but it should not be a royal flush. Then how many different straight flushes are there? You can see one example of straight flush is here. You can see all 5 cards in the same suit. You can see here the suit is spades and 5 consecutive denomination. You can see 2, 3, 4, 5, 6. These are the consecutive denomination. And remember, the royal flush, that is not a straight flush. Means we need to ignore the royal flush. Okay, we should not count the royal flush because straight flush does not contain royal flush. Okay, I hope it is clear. And a very important note is given to you. Read the note for the ace card. What this is saying, for this straight flush, for this particular question, this note is given to you. So read this. Ace may be considered as the highest or lowest in the straight flush. but not both at once. What they want to say? They want to say that in the straight flush, you can consider ace as the highest. For example, look at this. Here we have all the five cards in the same suit. The suit is heart. All the five cards in the same suit, and you can see that here here you can notice that this denomination, these are consecutive. Okay, actually this is not a straight flush because this is a royal flush. Okay, look at this. This is not a. Notice here a very important note related to ace card is also given to you, but let me clear it that actually this is wrong here, because remember this 10 jack queen king all in the same suit, that is actually a royal flush. Royal flush is not a straight flush. Okay, so let me make this correction. Okay, let me make it this correction. I'm making it now. You can see what this question is saying. The question is saying that ace may be considered as the highest or lowest in the straight flush, but not both at once. Means you can consider ace as the highest or as the lowest. For example, look at this example. In this example, ace has been considered, this ace card, this has been considered as the lowest rank. Okay, you can see we have five cards all in the same suit, and the consecutive denomination. You can see ace, 2, 3, 4, 5. So here ace has been considered as the lowest rank. Okay, but remember, you cannot consider something like this. For example, you can see you cannot turn the corner. Read this note that you cannot turn the corner. Here you can see you cannot do this, that you are taking, jack queen king, then ace 2. You cannot do this, because here if you see this example, you can notice here ace is neither the highest nor the lowest. Okay, if you look at this, or I can say that here ace is both the highest, both the lowest. Look at this example. In this example, ace is both the lowest, both the highest. For example, in this example, if I ask you what is the highest, then what you will say? You will say ace. Ace is highest. In this example, if I ask you what is the lowest, then also you will say ace. Ace is the lowest. So this is what I am saying, that you can consider ace as the highest or you can consider ace as the lowest, but you cannot consider ace as both at once. Okay, so this type of example you cannot do. Okay, in simple words, if you did not understand this, then let me tell you in simple words, you cannot turn the corner. You assume that ace is lowest also, ace is highest also. Okay, you consider ace as the highest also, lowest also, but you cannot turn the corner. Okay, means you cannot do something like this, that you are taking, king ace 2 3 4. You cannot do like this. So this is invalid. I hope you understood the definition of straight flush. I hope you understood. Okay, so let's solve this question now. I hope you understood the definition of straight flush. You can see the complete definition is given to you. Now, after understanding the definition of straight flush, let's solve it. So you can see what is a straight flush. This is five cards all in the same suit. Consecutive denomination. All the five cards, they must have the consecutive denomination all in the same suit, but it should not be a royal flush. Okay. So let me tell you here how to solve this question. You can see. First, let me write the values. Okay. First, let me write the denomination or values. You can see the important point was that you can consider ace as the highest or as the lowest, but it should be either the highest or it should be lowest. It should not be both. Okay, so that explanation I have already provided to you. But basically the point is that what you can do when you write the values, then you can write like this, that you can start with ace, means you consider ace as the highest also, lowest also. Okay, so basically these are the values: ace 2 3 4 and so on. 2 3 4 5 6 7 8 9 10, jack, king, queen, jack, 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 queen, king, ace. Notice what I'm doing. I'm writing ace here also, ace here also. What is the reason? The reason is simple, because the question is saying, if you read the question, it is basically saying that you can consider ace as the lowest, or you can consider ace as the highest. Okay, but you cannot turn the corner, means you cannot do this, that okay, you are taking king and ace from here and 2 3 4 from here. You cannot do that. Okay, means you can consider ace as the lowest, or you can consider ace as the highest, but you cannot turn the corner. For example, you cannot do this, that okay, you are taking 3 from here, 2 from here. You cannot do that. Okay, I hope it is clear. So this is how you can write the values. Now let's see. Now you can see, first we need to choose the suit, because remember, what is a straight flush? This is 5 cards all in the same suit. So first you pick the suit. Okay, so remember, there are 4C1 ways to pick the suit. Okay, pick a suit, because all the 5 cards, they will have the same suit. So to pick a suit, there are 4 ways that you already know. Okay, now once you have picked the suit, for any particular suit, you can see I need 5 cards, 5 consecutive values I need, 5 consecutive values I want. Then you can see that I can start from here, then I can take these 5 consecutive values, correct? These 5 consecutive values I can take, or I can start from here and I can take these 5 consecutive values, or I can start from here, I can take these 5 consecutive values. I hope you are getting the point. Okay, so very simple point, that I can start from ace and I can take these 5 consecutive values, or I can start from 2 and I can take these 5 consecutive values, or what I can do, I can start from 3 and I can take these 5 consecutive values, or I can start from 4 and I can take, these 5 consecutive values, and so on and so on. You can see, at last you can notice that I can, at last, I can start from 10 and I can take these 5 consecutive values. But remember, I cannot start with jack. If I start with jack, then you can see I don't have 5 cards. Okay, so in worst case, I can start with 10. You can see I can start with 10 and I can take these 5 consecutive values, correct? Okay, so very simple. So you can notice that first you pick a suit, because straight flush, this is 5 cards all in the same suit. So first you pick a suit. Once you have picked the suit, then in that suit we need 5 consecutive values we want. So I can start with ace, I can start with 2, or I can start with 3, and so on. I can start with 10. So from ace to 10, there are total 10 values. So from these 10 values, I can choose one value. From these 10 values, I can choose one value. Basically, this 10C1, what it means? It means that from where I am starting, means I am choosing the start point. Choosing the start point. Okay, I am choosing the start point. I hope you understood. Basically, I am choosing the start value, I can say. Okay, is this clear? So first I'm picking a suit, because all the 5 cards must have the same suit. So I'm picking a suit. There are 4 ways to pick a suit. In that suit, 5 consecutive cards I want. So I'm picking the starting value, means from where I can start, because I want 5 consecutive values. So from where I will start. So there are 10 ways to start. I can start with ace, or I can start with 2, or I can start with 3, and so on. I can start with 10. So you can see from ace to 10, there are total 10 starting values. So basically, I'm choosing the starting value. 10C1 means I'm choosing the starting value. But now notice one thing here, that if I do this, then the royal flush also I have counted. Yes or no? Please notice that these 5 cards, if you are taking 10, jack, queen, king, ace, all in the same suit, if you take, then that will be a royal flush. Okay, do you agree? This will be a royal flush. So remember, this royal flush, the number of royal flushes we have to subtract, because remember, if you are starting from 10, then 10, jack, queen, king, ace, all in the same suit, that will be a royal flush. In the previous question, we have already seen what is a royal flush. We have counted the number of royal flush. Total we have 4 royal flushes. So remember, if you are starting from 10, then this is a royal flush. This we do not want to count, we want to remove it. So you can see, from this value I will remove 4, and this 4 I will remove for the royal flush. This I am removing for the royal flush. I hope you understood. So you can see, finally I will get 4 into 10 minus 4, that is 36. This is the number of straight flushes. Okay, I hope you understood this. Very simple. This explanation, is it clear to everyone? So I can say this is method number 1. Okay, let me tell you that this is method number 1 to solve this question. Let me tell you another method to solve this question. But I hope you understood this explanation. Now let's see the method number 2 to solve this question. See, method 2 is also very simple. You can see first we will pick a suit because straight flush, this is a 5 card hand, 5 cards all in the same suit. So first you pick a suit. Once you pick a suit, then for that suit we need 5 consecutive cards, or I can say 5 consecutive values we want, correct? Okay, so you can see the starting value can be a, or the starting value can be 2, or the starting value can be 3, and so on and so on. Notice one thing, the starting value cannot be 10, because if you start from 10 then you will get a royal flush. And remember, the straight flush is not a royal flush is not a straight flush. Okay, so basically they are disjoint. You can notice the question is saying that straight flush is not a royal flush. Okay, so you can see that the starting point, once you pick a suit, then the starting point can be ace or 2 or 3 and so on, but it cannot be 10. If you start from 10, then 10 jack queen king ace, this will become royal flush, so you cannot start with 10. So in worst case you can start with 9. If you start with 9, then 9 10 jack queen king ace, this you can take, yes, this is a straight flush, this is not a royal flush. So very simple point that what you do in worst case, you can start with 9. So now you can see that from ace to 9 there are total 9 ways. Okay, so remember 9c1 I will do. Why I am doing this 9c1? Because once you pick a suit, then to choose 5 consecutive values, what will be the starting value? The starting value can be ace, or it can be 2, or it can be 3, and so on, or it can be 9. From ace to 9 there are total 9 ways. So you can see this 9c1, this is I am doing for choosing, I am choosing start value. Okay, yes or no? So in the method 1 also the same thing we were choosing start value. But there what we were doing in the method number 1, this 10 also we were considering as the start value. Then that is the reason we were removing the number of royal flushes. Okay, this subtraction we were doing. But if I stop here, means if I do not consider 10 as the start value, then I don't have to remove the number of royal flushes, because now I will not get a royal flush, because I'm not starting with 10. If I don't start with 10, then I will not get a royal flush, so I will not have to subtract the number of royal flushes. So I can stop here. Basically I can start with ace and so on. I can start with 9. So from ace to 9 there are total 9 ways for the start value, for the start card value, starting point. Okay, so that's it, this is the answer. So you can see finally this will be 36. The same answer we got using the method 1. You can see the 36 answer we got, and the same answer we got here. So 36 straight flushes are there. Okay, so I hope you understood both the methods, method 1 also, method 2 also. Is this clear to everyone? Please tell me. So you can read this explanation here. For straight flush, the final answer will be 36. You can read the complete explanation, everything we have seen. Now, what are the odds of getting a straight flush from 52 cards? If I give you 5 cards, what is the probability, what are the odds, what are the chances that you will get a straight flush? So let me tell you, that is once in, almost approximately once in 72,000, approximately. So you can see that these are better odds, these are better chances than royal flush, but these are worse chances than one pair poker hand. Okay, so you can see so far what we have seen one pair poker hand, we have seen royal flush, we have seen straight flush. Out of these three, which of them has the more chances, more probability, or I can say more more odds? Okay, more chances, more odds, more probability. So you can see one pair poker hand that has the more probability, and then this royal flush has the least probability, least odds, and this straight flush, this is somewhere between once in, almost approximately once in 72,000. Okay, so you can see this straight flush, this also has a good worth, I can say, because once in 72,000, that is the odds of getting a straight flush. Okay, I hope it is clear. Let's move on now. So far these three questions, are they clear? Let me know. Okay, so let's see now. Let's solve question 5. Counting the flush poker hands. The definition of flush poker hand is given to you. Remember, in the previous questions, we have seen straight flush, we have seen royal flush, but now we are considering flush. Okay, already we have seen royal flush, straight flush, those already we have seen in the previous question. You can check it out. But here, the flush definition is given to you. You read the definition and solve the question. A flush, this is a hand that has five cards, means five card hands which all the five cards of the same suit, but not a straight flush, means five cards of the same suit, but it should not be a straight flush, it should not be a royal flush. Okay, the simple point that you must have five cards in the same suit, but we are not saying that you must have five consecutive values. Okay, you can see the values must not be consecutive. That this is the simple point. Okay, means a flush, this is a five card in the same suit. In the same suit, choose any randomly five cards, but make sure that it is not a straight flush. Make sure it is not a royal flush. This example is given to you. All the five cards in the same suit. The suit is club here, and you can see this is not a straight flush. This is not a royal flush. So this is a flush. Okay, I hope it is clear. Okay, you can see 3, 6, 8, 10, jack, all in the same suit. So this is a flush. This is not a straight flush. This is not a royal flush. Now let's count the number of flush poker hands. So you can see, to have this flush poker hand, we need five cards in the same suit. So first you pick a suit. Very simple. 4C1. This is to pick a suit. Notice all the five cards, they must be in the same suit. There are four suits. One of them you choose because all the five cards they must have the same suit. So first you pick a suit. Once you pick a suit, then you can see for that suit there are 13 values. For every suit there are 13 values, right? And for every value there are four suits. Okay, so you can see that first you pick a suit because all the five cards they must have the same suit. First we are picking the suit. Then once you pick the suit, then for that suit there are total 13 values. From those 13 values you choose five values. I want five values. Okay, yes or no? I want five values. I want. Now from those 13 values you are choosing five values. That's it. But remember, when I do this, then you can see that here, once you pick a suit, then in that suit, out of 13 values, you are choosing any five value. Then maybe it might be possible that you are choosing five consecutive values, or maybe you are choosing a straight flush, or maybe you are choosing a royal flush. Do you agree with me? See, in this calculation, if you see this complete calculation, in this calculation, the straight flush are also counted, the royal flush are also included. Straight flush, royal flush, both are included. Because what we are doing, we are picking a suit, all the five cards in the same suit, and then we are picking five cards out of 13 cards for that suit. For that suit there are 13 cards. Out of them we are choosing five cards. But you can see if we do this, and then in this calculation, the straight flush is also included, royal flush is also included. So what we need to do, we need to remove the number of straight flush that we have seen 36 in the previous question, and the number of royal flush also we need to subtract, that is 4. The number of royal flush is 4 in the previous question we have seen. So you can see this 36 we are removing for straight flush, the straight flushes we are removing, and you can see this 4 we are removing for royal flush. So royal flushes we are removing. I hope you understood this. Okay, so this is your answer. So this is the total number of flushes. You can see a flush, this is basically a set of five cards all in the same suit, but it should not be a straight flush, it should not be a royal flush. So you can see, first you pick the suit because all the five cards must have the same suit. Then in that suit there are total 13 values or 13 cards. Out of them you choose five cards. But you can see in this straight flush is included, in this royal flush is included. So you subtract the number of straight flushes, you subtract the number of royal flushes. The number of straight flushes, the number of royal flushes we have already counted in the previous questions. You can watch it. So that's it. This is the final answer. I hope you understood. If you calculate this value, then what you are going to get, you will get 5108. This is the answer you will get. You can check it out. This explanation you can pause and you can read it. Basically, we have already seen this. Okay, so you can see, first you are picking a suit, that is 4C1, or I can say 4 multiplied by, out of 13 cards of that suit, For that suit, there are 13 cards. Out of them, you are choosing 5 cards. So now these, but from this, I need to remove the number of straight flushes. I need to remove the number of royal flushes. So you can see straight flushes plus royal flushes, that is total 40. So that I am removing. Finally, this is the answer I am getting. You can see 5108. Okay, so let me tell you, this is the value you will get. 5108. This is the final answer. Okay, 5108. I hope you understood this. Now you can find the probability also. What is the probability of getting a flush? So you can see the total number of flushes, that is 5108 divided by the total number of 5 card hands. Okay, so you can see the odds, the chances, the probability of getting a flush, that is 1 in 509. So these are kind of good odds, I can say. Yes or no? If you compare these odds with the odds of royal flush, with the odds of straight flush, then these are comparatively good odds, that once in almost once in 500 times basically you will get this flush you will get. Okay, so these are kind of good odds, I can say. I hope it is clear. So far we have seen total 5 questions. Are all of them clear? In the live chat, let me know. So far the 5 questions that we have seen, all of them are clear? Let's solve question number 6, counting the straight poker hands. Remember, in the previous questions we have seen what are straight flush, that is different. Straight flush is different, straight is different. Okay, here the definition of straight poker hand is given to you. You read the definition carefully, understand the definition, and then solve the question. In the previous questions we have seen what is a straight flush and what is the number of straight flushes, that we have seen, but that is different. Okay, and what is a royal flush, that also we have already seen in the previous questions. What is a straight flush, that we have already seen in the previous questions. So those we have done. Now let's solve this straight. What is this straight poker hand? Let's understand the definition. A straight is a hand of 5 cards in consecutive denomination. But here you can notice that 5 cards in the consecutive rank, 5 cards in the consecutive values, but here you can notice that the suit will be different. Okay, means not all in the same suit. It will not happen that all the 5 cards have the same suit. It will not happen. So you can see a straight is a 5 card hand. The 5 cards, they must have consecutive values, consecutive denomination, but it is not a straight flush, it is not a royal flush. How many such hands are there? So you can see that straight, this is 5 cards in a sequence, means consecutive values, not all of the same suit. It should not happen that all are having the same suit, because if all have the same suit and consecutive denomination, then either it will be royal flush or it will be straight flush. Do you agree with me? If you have 5 cards in the same suit and consecutive denomination, then it will be either a royal flush or it will be a straight flush. But here you can see we want 5 cards in consecutive denomination, which is not a straight flush, which is not a royal flush. So I can say that not all cards have the same suit. Means you must have at least 2 suits in these 5 cards. At least 2 suits should be there. Okay, so you can see 5 cards in a sequence, but not all of the same suit. The definition of straight is given to you. This consists of 5 consecutive ranks, not all of the same suit. And a very important note is given to you for the ace card. Read this. This is a very important note. For this straight poker hand, this will be given to you in the question. Okay, when the question will come on the straight poker hand, then this line, this statement related to ace, this will be given to you. You can see ace can be considered as the highest rank or as the lowest rank in the straight, but you cannot consider both at the same time. What it actually means, let me explain. See, you can notice if you consider these 5 cards, just notice these 5 cards. Here you can see that not all cards have the same suit, because you can see here diamond is also there, heart is also there. Okay, so these 5 cards, they 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 have at least 2 suits, or I can say that not all of them have the same suit. And the second point, that if you see jack, sorry, 10 jack queen king ace, this is consecutive denomination also. So yes, this is a straight. Okay, and notice in this straight, this ace is considered as the highest rank. I told you that ace can be considered as the highest rank. In this question it is given to you that ace can be considered as the highest rank. So you can see, look at this 5 card hand. Here you can see not all cards have the same suit. Here we have diamond also, we have heart also, and you can see that we have consecutive 5 values: 10, jack, queen, king, ace. Here you can notice that ace is considered as the highest rank. Look at this example. In this example also we have 5 cards, and we have diamond also, heart also. So basically not all cards have the same suit. And you can notice that here ace is considered as the lowest rank. Basically ace 2, 3, 4, 5. So ace is considered as the lowest rank here. So in this example ace is considered as the lowest rank. In this example ace is considered as the highest rank. Okay, both are valid. You can see both are valid states. But notice, look at this example. In this example, if I ask you what is the highest value, that is ace. In this example, if I ask you what is the lowest value, that is also ace. This is what I am saying, that you can consider ace as the highest value or lowest value, but not both at once. In this example, ace is highest value also, lowest value also. So this is not valid. In simple words, if you did not understand this, then in simple words I can say that you consider ace as the lowest value also, you consider ace as the highest value also, and do not turn the corner. Means don't do this, that okay, some you are taking from here, some you are taking from here. So don't do that. So in simple words, this ace you consider as the lowest also, highest also, but don't turn the corner. Okay, don't turn the corner. Okay, so if you take 5 from here, then ace will be the minimum value. If you take 5 from here, then ace will be the highest value. You can consider ace as the highest value or lowest value, but you cannot consider ace as both highest and lowest at the same time. Okay, for example, in this example, ace is highest also, lowest also at the same time. This is invalid. Okay, I hope you understood. If you did not understand, don't worry, I will explain. Okay, what this statement means related to s, what this statement means, I will explain. So let's see what is the number of straight poker hands. Okay, so basically what this statement means in simple words, let me tell you. In simple words, it simply means that these are the values, these are the card values. Ace you consider as the lowest also, highest also. Ace 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Again you write ace. See, what is the reason I'm writing ace? Because now you can see, if you take 5 consecutive values from here, if I take 5 consecutive values from here, then ace will be the lowest value. If I take 5 consecutive values from here, then ace will be highest value. And don't turn the corner. Means don't do this, that okay, you are taking 3 from here, queen, king, ace, and 2 from here. This you cannot do. Okay, don't turn the corner. For example, you are taking 2 from here, 3 from here. Don't do that. Okay, I hope you understood. But remember, yes, this is perfectly fine. Here ace is the lowest. This is also perfectly fine. Here ace is the highest. Okay, so I hope you understood this. Basically, what this statement means in simple words, this is what it means, that you consider ace as the lowest also, highest also, but don't turn the corner. Okay, correct? Just give me a second. Okay, just give me a second. Hi all, just give me 2 minutes. Okay, there is some important work came. Just give me 2 minutes. I'm coming back. Okay, we will finish it today. Okay. Hi all. So let's resume. Welcome back. Audio, video, volume, everything is fine. Let me know. So let's resume now. Okay. Now let's count the number of straight. Now let's count the number of straight poker hands. So what is a straight poker hand? 5 cards in consecutive denomination. So you can see 5 cards in the consecutive denomination. If we are taking, then you can notice we cannot start with jack. If I start with jack, then we don't have 5 cards. So you can see I can start with ace, or I can start with 2, or I can start with 3, and so on. I can start with 10. Okay, but I cannot start with jack, because if I start with jack, then I don't have 5 cards. Okay. Okay, so yes. Okay, so first 5, then we can remove the number of straight flush and royal flush. Okay, so that we can do. Okay. Okay, so now we will count the number of straight poker hand. What is a straight hand? Straight poker hand. This is 5 cards in the consecutive denomination. If we are taking 5 cards in the consecutive denomination, then I can start with ace. If I start with ace, then these 5 consecutive denomination I can take. I cannot start with jack. If I start with jack, then I don't have 5 cards or 5 values, right? So I can start with ace. In worst case, I can start with 10. If I start with 10, then I can take 5 values I can take. Okay, but I cannot start with jack. So you can see that here I can say we want 5 consecutive values. Then I can start with ace. This can be the starting point or starting value. Or I can start with 2. If I start with 2, then these 5 consecutive values I can take. Okay. Or I can start with 3. Or I can start with 4, and so on and so on. In worst case, I can start with 10. Okay, I cannot start with jack, because then I don't have 5 consecutive values, correct? Okay, so you can see that these can be the starting point. Now let me do one thing, that first let me choose the starting point. Okay, you can see the starting point can be ace, or it can be 2, or it can be 3, and so on. It can be 10. From ace to 10, there are total 10 starting points possible. So you can see from 10, let me choose one, means the starting point I am choosing. Okay, so remember, here you choose the starting point, choose start value, because once you have the start value, then 5 consecutive values you need. Once you have the start value, for example, once you have this start value 6, then 5 consecutive values you will take. Okay, so you just have to choose the start value. The start value can be ace, or it can be 2, or it can be 3, or it can be 4, and so on. It can be 10. So out of these 10 possible start values, we are choosing one start value. Okay, so that is 10c1. Now, once you have chosen the start value, let's assume that you have chosen the start value, that is 7. Then you can see that 5 consecutive values you will take. Okay, these 5 consecutive values you will take. But remember, for each value, there are 4 cards for each value. We already know for every value there are 4 cards in the 4 suit. For every value there are 4 cards in the 4 suit. For every value there are 4 cards. So you can see for each value I just want one card. Correct? So for every value I have 4 cards, but I just want one card. So you can see that 4c1, 4c1 into 4c1 into 4c1, and so on. So basically 4 power 5. I hope you understood. So remember, here I will do 4 power 5. This is very simple. I hope you understood. Basically what we are doing, First, we are choosing the start value. The start value can be ace, or it can be 2, or it can be 3, and so on. It can be 10. First, we are choosing the start value because we want consecutive 5 values. So once we have the start value, for example, if we have the start value 7, then these 5 consecutive values I will have. Okay. So basically, we just need to choose the start value. There are 10 possible start values. We need to choose one of the start values. Okay. Once you have the start value, if the start value is 7, then you can see that these 5 consecutive values I will choose. Okay. Now, in these 5 consecutive values, every value has total 4 cards, but I just want one card of that value. So you can see that what we are going to do, we are going to do, 4 into 4 into 4 into 4 into 4. Okay, into 4. So you can see that this is what we are doing, because for each value we are taking one card. Okay, for each value choose one card. Okay, choose one card. Simple. Okay, so this is the idea. But now remember, if you do this, then here you have counted state flush also, you have included state flush also, royal flush also. Because notice one thing, if the start value is 10, let's assume if the start value is 10, then these 5 values you are taking 10, jack, queen, king, ace, these 5 values you are taking. In these 5 values, for each value there are 4 cards, and for each value you are choosing one card. So you can see it might be possible that when the start value is 10, then it might be possible that all the all for each value you are having the same suit, then it will be royal flush. Are you getting my point? I am saying that in this calculation the royal flushes are included, because if the start value is 10, then it might be possible that for each value you are taking the same suit for each value. Okay, means all the values same suit. Okay, so you can see that will become a royal flush. So in this calculation the royal flushes are included. I need to subtract the number of royal flushes. So this 4 I am subtracting for royal flushes. The total number of royal flushes, that is 4, that we have already seen in the previous question. You can check it out. Now you can see one more thing you can notice. In this calculation the state flushes are also included, because if you are, let's assume that the starting point is 5. If the starting point is 5, then you can see maybe you are choosing same suit for all these 5 values. Okay, for all these 5 values maybe you are choosing same suit. For these 5 consecutive values, if you choose the same suit, that will be a straight flush. Yes or no? So you can see that in this calculation the straight flush are also included. That also I have to subtract. So 36 I have to subtract for straight flushes. Okay, so very simple point that in this calculation the straight flushes are included and the roll flushes are included, that we have to subtract. Okay, so finally the answer will be, this is the final answer. I hope it is clear. If you calculate this value, what you are going to get, so you can see that, you can see 10 into 4 power 5, that we have already seen. 10 into 4 power 5 minus 40, total 40. So you can see minus 40. So you can see the final answer will be 10,200. Okay, so let me just write it here, that this final value, if you consider, that will be 10,200. Okay, 10,200. This is the final answer. I hope you understood. You can find the probability also. What is the probability of getting a straight? The probability of getting a straight, that is the total number of straights divided by the total number of 5 card hands. Okay, so you can see the probability of getting a straight, that is almost this much, or I can say the odds of getting a straight, the chances of getting a straight, that is almost once in 255. Okay, almost. So these are quite good chances, I can say. Okay, if you compare these odds with the odds of flush, then these are better odds. Okay, we have already seen in the previous question that what are the odds of getting a flush, that was almost once in 500, almost. Okay, and getting, what are the odds of getting a straight, that is once in, almost once in 255. Okay, so these are quite good odds, I can say. I hope it is clear. Understood? Everything is clear so far? Let me know. Let's solve question number 7. Counting full house poker hands. The definition of full house poker hand is given to you. 3 cards of same rank and 2 cards of another rank. Basically, total we must have total two values we must use. For one value, two cards. For one value, three cards. Okay, I hope you understood this. See, very simple question. What is a full house in the poker? Full house means three cards of one rank. For example, here, three cards of same value, 777, three cards of same value, and two cards of another rank, two cards of king. Okay, so you can see that this is called full house. Here you can notice three cards of same value, three cards of value 5, two cards of value 4. Okay, so you can see three of a kind plus a pair means you must have three of a kind plus a pair. This is called full house. This is very easy to understand definition, correct? Okay, so let's see what is the total number of full houses. You already understood what is a full house. Full house means that three of a kind or three cards of same value and two cards of a different value. Okay, but remember, two cards, these also must be a pair. So you can see it's like three of a kind plus a pair, three of a kind plus a pair. Okay, so total you can notice we are having basically two values we are using here. 7 comma king we are using, in this example 5 comma 4 we are using. I hope it is clear. Okay, so you can notice how to find the total number of full houses. This is quite simple, that total we have 13 values. From those 13 values you choose that value for which you will have three of a kind, means you choose that value for which you will have three cards. So remember, total 13 values are there. For from these 13 values you choose one value, and this one value will have three cards. Okay, for three of a kind, for three of a kind. Okay, is this clear? Because we want three cards of same value. So you can see total we have 13 values. Out of them choose one value. For this one value we will have three cards. So that is the reason I am saying that this one value I am choosing for three of a kind. Okay, once this value has been chosen, then for this value there are total four cards, but I want three of them. Do you agree with me? For every value there are four cards, because for every value there are four cards in four suits. So you can see that for this value we want three cards. Actually, for this value, total available cards are 4. Out of them, we want 3 cards. So that is the reason 4C3. So now you can see that this 4C3 we are doing. So basically, now we have 3 of a kind. 3 cards of same value we have. Now we have 3 cards of same value. Correct? Okay. Now what we want? We want a pair also. Okay, because you can see what is a full house. That is 3 of a kind that we have already taken, plus a pair. Now we want a pair, means we want a value for which we will have two cards. Okay, so you can see already this three of a kind we have taken. Already this value we have considered for which there will be three cards. So you can see the remaining how many values are there? 12 values are remaining. Out of the remaining 12 values, you choose one value. For this value, you will have the pair. For for a pair, for the pair. Okay, this value you are choosing for the pair. Okay, so you can see remaining 12 values are remaining, because already one value we have already considered for which there are three cards. Now 12 values are remaining. From these 12 values you choose one value, and for this value you will have a pair. So you can see the value that you have chosen, for that value actually there are four cards there in four different suits, but I just want two of them. I want a pair. Okay, so you can see now this is the pair. So that's it, this is the answer. Simple, right? So counting the number of full house, actually that is very easy. Okay, all you have to do, first you consider the value for which you will have three cards. Okay, so there are 13 values. Out of them choose one value, and for that value you need three cards. And then you choose the value for which you will have two cards. So you choose a value, and for that value there will be two cards. Okay, this is the final answer. This is the total number of full houses. I hope it is clear. Simple. Okay, so far all the questions are clear. Let me know. This is the complete explanation. You can read it. We have already seen this. And what are the odds of getting a full house? What is the probability of getting a full house? So you can see the total number of full houses divided by the total number of five card hands. So the odds, the chances, the probability of getting a full house, that is 1 in almost 700. Okay, so almost I can say once in 700. This is the odds, this is the chances, this is the probability of getting a full house. Okay, I hope you understood. Let's solve question number 8. Counting 4 of a kind poker hands. The definition is very simple, that out of the 5 cards, we want 5 cards, but out of them 4 must be having same value. Okay, so you can see 4 of a kind. The name itself is telling you 4 of a kind means 4 cards of the same value and one extra card, because total we want 5 card. Yes or no? For each value we know there are 4 cards only. For each value maximum there are 4 cards for each value. Okay, so you can see here I want 4 of a kind means out of 5 cards I want 5 cards total, but out of them 4 cards of one same value and one extra card, any extra card. Okay, so that is called 4 of a kind. Here example, you can see 4 cards of value 4 and one extra card, that can be anything. You can see in this example also, you can see 4 cards of value 5 and one extra card. Okay, I hope it is clear. So 4 of a kind means 4 of a kind, that means that 4 card of the same value and plus one extra card. Okay, so let's see this. You can see 4 of a kind, that means 4 card of the same value and plus one extra card. Okay, so what is the answer here? What is the total number of 4 of a kind? So that is very simple, that I want to choose a value, and for that value all the 4 cards I will choose. Okay, so remember there are total 13 values available, correct? 13 values are available. From these 13 values I will choose a value. Now this value that I am choosing, for this value I will have 4 cards. For this value I will have 4 cards. So I can say that this is the value. This is the value for 4 of a kind. This is the value I'm choosing for 4 of a kind. So once I choose this value, then for this value I will choose all the 4 cards. Actually for each value there are 4 cards only. Yes or no? For each value there are 4 cards in the 4 suits. And you can see in this 4 of a kind, once you choose this value for 4 of a kind, then for that value all the 4 cards you will choose. Total 4 cards are there, all of them you will choose. Okay, now you can see, now we have 4 of a kind. Now we have 4 of a kind. Because once you choose the value for 4 of a kind, then for that value total 4 cards are available. I want all 4, so 4c4. Okay, then you can see plus, once I have these 4 cards of the same value, then plus any fifth card. Any fifth card is fine. Total how many cards are remaining? Tell me. Total how many cards are remaining? Total 48 cards are remaining. Any of them is fine. Okay, these are the remaining cards. Any one of them is fine. So this is the any fifth card. Okay, do you agree with me? Very simple, that once you have taken 4 of a kind, once you have taken, then any fifth card is fine. Plus any fifth card. Okay, so the remaining cards are 48. Already 4 cards I have chosen. So the remaining cards are 48. From them, any fifth card means any one card I can choose, that will be my fifth card. So you can see 48. 48 ways are there. This is your final answer. I hope you understood. Okay. So quite easy. The same thing what you can do here, instead of 48c1, instead of that, what you can do? You can do like this, that see, for this value we have chosen a value. For this value 4 cards we have taken. Now how many values are remaining? Total 12 values are remaining. From them you choose one value. Okay, the remaining total 12 values are remaining. From them you choose one value, and for that value there are total 4 cards, but I just want one of them. Okay, if you see, this also will be 48. If you notice, this also will be 48. Okay, so you can see that either you can directly do 48, or you can do like this, that okay, there are 12 values are remaining. From those 12 values you choose one value, and for that value there are 4 cards, but I just want one card. Okay, the overall it will be 48, and the same 48 you can multiply here, because any fifth card is fine. Okay, I hope you understood. Simple, right? This is the explanation. You can read this explanation, pause the video and read it. This we have already seen, this explanation. What are the odds of getting 4 of a kind? What is the probability of getting 4 of a kind? That is the total number of 4 of a kind poker hands divided by the total number of 5 card hands. So the odds, the probability, the chances of getting 4 of a kind, that is once 1 in almost 4,000, almost 4,000 I can say. So almost 1 in 4,000. So these are the odds of getting a 4 of a kind. I hope it is clear. Simple. Let's solve question number 9. Counting 3 of a kind poker hands. The definition is given to you. 3 of a kind means 3 cards of the same rank, 3 cards of the same value, and 2 cards of different value. Means we must have 3 of a kind. We must not have 4 of a kind. Please understand. We must have 3 of a kind. We must not have 4 of a kind. Means it should not happen that you have 4 card of the same value. No. 4 of a kind, 4 of a kind we have already calculated in the previous question. The previous question was about 4 of a kind. This question is about 3 of a kind. 3 of a kind means you must have 3 cards of the same value, and then you must have two different value cards, and for those two different value cards the value must be different from this value. Okay, so you can see 3 of a kind means you must have 3 of a kind plus there should be no pair, and you should not have any 4 of a kind. I hope it is clear. Read this. 3 of a kind, it means consisting of 3 cards of same rank, 3 cards of same rank, here 3 cards of rank 2. Okay, 3 cards of same rank, and then there are 2 more cards of 2 further ranks, 2 different ranks. You can see. Okay, I hope you understood. So remember, 3 of a kind, you must not have here 4 of a kind. Means you cannot take 4 cards of value 2. No, we want 3 of a kind, and then the remaining 2 cards must have different rank, and the rank of these 2 remaining cards that must be different from this. I hope it is clear. Okay, so let's see this. 3 of a kind, total number of 3 of a kind poker hands, what that will be? First you choose the value for which there will be 3 cards. Correct? There are 13 values there. You choose one of them. We already know 13 values are present from 2 to ace, 2, 3, 4, 5, and so on. Jack, queen, king, ace, total 13 values are there, 13 denomination, 13 ranks are there. Out of them you choose one value. For this one value, basically this value that you are choosing, for this we will have 3 cards because we want 3 of a kind. So you can see that here I am choosing value for 3 of a kind. Okay, so once you have chosen this value for 3 of a kind, then for this value, actually total 4 cards are there in 4 different suits, but I just want 3 of them. Okay, yes or no? For any value, there are 4 cards in 4 different suits, but here you can see for this chosen value, I want only 3 cards. So you can see that out of 4, I want 3 cards. Now I have 3 of a kind. Now I have 3 of a kind. Once I have 3 of a kind, then you can see I need 2 more cards of different rank, different values. Remember, this value that you have chosen for 3 of a kind, this value you cannot use here. So how many values are remaining? 12 values are remaining. Okay, from the remaining 12 values, you choose 2 values. Yes or no? Because I want 2 more cards. So you can see total 12 remaining values are there. From those 12 remaining values, you choose 2 values. For these 2 values, I will have one card. So here you can see that these are the values for remaining 2 cards. For remaining 2 cards. Okay, so you can see once I have chosen values for the remaining 2 cards, then for these values, for each value, actually there are total 4 cards, but I just want one of them. Yes or no? So 4c1 into 4c1. I hope you understood. Very simple point that this value that you have chosen for 3 of a kind, this value you cannot choose for the remaining 2 cards. So from the remaining 12 values, 12 values are remaining, from them you choose 2 values for the remaining 2 cards. Once you have chosen the values, 2 values you have chosen, then you can see for each value there are actually 4 cards in the 4 suits, but I just want one of them. For each value I just want one of them. So 4c1 into 4c1. Okay, so this is the final answer. I hope you understood. Quite easy. You can read this explanation. We have already seen this explanation. Basically, you can read it, you can pause the video and you can read it. What is the probability of getting 3 of a kind? So probability of getting 3 of a kind, that is total number of 3 of a kind poker hands divided by the total number of 5 card poker hands. So that will be 1 in 47. Okay, so you can see the odds, the probability, the chances of getting three of a kind. This is actually quite good, I can say. Almost 1 in 47, almost one time out of 47, you will get three of a kind. So this probability, these odds are quite good, I can say. Okay. So far, everything that we have seen, did you understand? Let me know. Everything is clear so far? All the questions? The last question is remaining that we will see now. Let's solve question number 10. Counting two pair poker hands. The definition of two pair poker hand is given to you. Read the definition, understand the definition, and solve the question. Remember, in the previous questions, we have seen what is one pair poker hand, what is four of a kind, what is three of a kind, what is royal flush, what is straight flush, what is straight. Yes or no? So basically, in the previous questions, many different type of poker hands we have defined, we have understood, and then we have counted their number. Now, this is the last question that we need to count the two pair poker hand. The definition of two pair poker hand is given to you. The name itself is telling you we want two pairs. You can see this is one pair, means two cards of the same value, two cards of value 10, two cards of value 10. So can you notice these are the two pairs, and this is any fifth card. Okay, yes, so remember this any fifth card, this must be different from these two values, because remember we want two pair, we don't want three of a kind, we are having two pair. Okay, so you can see, read the definition. Two pair, that simply means two card of one rank, for example two card of value 10, two card of another rank, two card of value 3, and another card of third rank, another card of third rank. Okay, another card of third value, I can say. So you can see two pair plus any fifth card, but remember this fifth card, this must be different from the value of these two pairs. Okay, so you can see, for example, this is a pair, two cards of value 5, this is a pair, two cards of value 4, and you can see this is a card of a third rank. Okay, I hope you understood. So now let's calculate the total number of two pair poker hands. Here you can notice I want two pairs, means there are two values for which I will have two cards. Do you agree? There are two values, 4 comma 5, these are the two values for which I will have two cards. Okay, total I have 13 values. 13 values are there in the standard deck of 52 cards. We have total 13 values, and for every value there are four suits. The values are 2, 3, 4, and so on. 10, jack, queen, king, ace. Okay, so you can see total 13 values are there. From these 13 values, I want to choose two values, because for those two values I will have two cards. For example, here you can see those two values are 5 comma 4. For these two values I will have two cards. So you can see from 13 values you choose two values. Okay, and these are the values for both pairs. Okay, there are two pairs, right? So you can see these are the values for two pairs. Okay, so I have chosen two values, I have chosen. Now for each of these values, two cards I will take. For each value, basically a pair I will take. You can see two values I have chosen. For each value, total four cards are there in four different suits, but I just want two of them. Okay, multiplied by again 4c2, because remember we have two values, and for these two values, total for each value four cards are available, but I just want, for each value I just want two cards. So you can see for each value I just want two cards. So now you can see this is one of the pair, this is another pair. Yes or no? I can say this is one of the pair, and this is second pair. Second pair. Okay, so very simple. So you can see this pair you got, this pair you got. Very good. Okay, then what else? Now I need a card of a third value, of a third value. Okay, the already the two values that you have chosen, now you cannot consider them. I want a card of a third value. So how many values are actually remaining? 11 values are remaining, because already two values we have chosen. Okay, for those two values we have taken basically two pairs we have taken. Okay, for those values, now you can see 11 values are remaining. From these 11 values you choose any one value, you choose from these 11 values you choose any one value, and then for that value Out of 4, only one card I need. Okay, so that's it. This is the final answer. You can see 13C2 into 4C2 into 4C2 into 44 basically. Okay, you can see 13C2 into 4C2 4C2 into 44. If you calculate, this will be the answer 123,552. Okay, so very simple. So this is the final answer for two pair poker hands. Okay, you can read this explanation, you can pause the video and read this explanation, but actually we have seen this explanation. What is the probability of getting a two pair poker hand? That is total number of two pair poker hands divided by the total number of five card hand. Yes or no? So you can see this is the probability, and if you see the odds of getting two pair, or the probability or the chances of getting a two pair poker hand, that is almost once in 21. So these are very good odds, I can say. Okay, so that's it. So now what we have done in this session, we have considered all the different type of poker hands that are there. Let me tell you, we have covered all of them, all the standard type of poker hands that are present, all of them we have considered. No other standard type of poker hand is there that we did not consider. Okay, so remember, in this session, all the questions that we have taken, these are standard type of poker hands, and all of them we have considered. We did not leave anything. That is one thing. Second thing, for each of them we have done the complete analysis. We have seen the definition, understood the definition, then we have calculated the total number of specific type of poker hands that we have calculated. We have seen the probability, we have seen the odds. Okay, we have seen the worth for any type of poker hand. If the odds are more, if the odds of getting that is more, if the probability of getting that is more, then the worth is less. Okay, if the odds are less, if the probability is less, then the worth will be more. Okay, in the poker game, basically in the casino or something, I don't know, I have never played poker. So overall, this these are the questions. I hope you understood. Okay, all the 10 questions, are they clear? Let me know. In this session, 10 questions we have done, all of them, are they clear? Please do share your feedback with me. If you have any doubt in any question, you can put a comment. Don't hesitate to put a comment. If you have any doubt in any question, then please do put a comment and I will reply to it. Okay, so don't hesitate. Now let's see the complete conclusion and what are the odds. So you can see we have counted the different type of poker hands we have counted. So let's see what is the conclusion and what are the odds of different type of poker hands. So you can see this table, you can check it out. We have counted the number of royal flushes. We have seen that the total number of royal flushes, that is 4. The probability is very less. The probability of getting a royal flush, that is actually very less. So you can see this has the more worth. Royal flush, this has the most worth, I can say, most worthy, most important, I can say. Then you can see the total number of straight flushes, that is 36. Total number of 4 of a kind, that is 6 to 4. Total number of full houses we have seen. Total number of flush, total number of straight, total number of 3 of a kind, 2 pair, 1 pair. Okay, can you notice that this is the order where the the count is increasing but worth is decreasing? Yes or no? Here the count is increasing, here the probability is increasing, but the worth is decreasing. This has most worth in the, from the poker game point of view. Royal flush, this is the most important, most worthy. And because this one pair, this has 42% probability, so this is less, I can say, less worthy. Okay, I hope you understood. So you can see the probability is also written here, and the total number of count is also basically written here. You can see, and you can see here, this is the summary, how many probability and what are the odds. Here you can see the odds are also written. You can check it out. For one pair poker hand, what are the odds? Almost 2 in 5. And you can see for royal flush, what are the odds? Almost 1 in 6.5 lakhs. Yes or no? What are the odds of two pair? Almost 1 in 21. What are the odds of 3 of a kind? Almost 1 in 47. So you can see here odds are written, probability is written, total how many, that is written, and these are the different type of poker hands. Okay, this is the complete summary. Now this is the homework question. In this session, total 10 questions we have solved, but now I am also giving you a homework question. This is important. So please take this question as a homework. If you understood everything in this session, then easily you can solve this question. So read this question and solve this question and write your answer in the comments. This is a homework. Maybe in future DPPs, I will solve it. Okay. So please understand. Today I am giving you homework also. 10 questions we have solved. Now 5 questions I am giving you as a homework. Okay, so please solve the question. Please pause the video, solve these 5 questions, write your answer in the comments. That is very important. So if you participate, then what I will do, we will continue this series, and also these questions, these homework questions also in the future DPPs I will solve. Okay, so I will not miss it, but in the future DPPs, maybe after 10 days, after 10 DPPs, 15 DPPs, maybe we will solve it. But the point is that you take these questions as a homework, you pause the video and you try to solve these questions and you write your answer in the comments. Writing your answer in the comments, that is very important. Please participate, it will motivate us. When we see that there are many comments, many likes, many comments, if you share with the gate aspirants, then that will be really very motivating for us, and we will keep bringing these type of standard questions for you to solve. Okay, so today I'm giving you this homework. Please write your answer in the comments. Okay, pause the video, solve these questions. Total 5 questions are there, and write your answer in the comments. Okay, the complete question is given to you. So that's it, everyone. If you find this session helpful, then please like, comment, and share. Please put a comment. That is very important. Please put a comment. If you participate, if you show interest, then we will keep bringing new unseen standard questions to solve. With complete analysis, we will provide you the solution also. So remember, your support will decide the future of our YouTube DPP series for GATE CS, GATE DA. So please participate, please like, please comment, and please share with the GATE CS, GATE DA aspirants. Okay. You can see on YouTube, you can put this in the search box, GATE CS DPP Go classes, or you can put GATE DA DPP Go classes, and you can see this GATE CS DPP, GATE YouTube DPP for GATE CS. This playlist will show. You can check it out. This playlist, you can check it out. Okay, and you can see in the description, the complete playlist link is also present, so you can check out the description, also the pinned comment. For GATE D aspirants, this is a very important news that for GATE D also we have started YouTube DPP series on our GATE DA YouTube channel. Go Classes has YouTube channel for GATE DA. You can see Go Classes for GATE DA, and we have YouTube channel for GATE CS. Go Classes for GATE CS. Total 2 YouTube channel we have right now. Okay, so you can check it out. You can, if you are a GATE DA aspirant, then do follow Go Classes for GATE DA, this YouTube channel, and on this YouTube channel, this YouTube DPP series for GATE DA also we have started. So please do check it out. Okay, so that's it, everyone. Thank you so much. I hope you enjoyed this session. We have done the complete analysis of 10 questions. We have covered all the different type of poker hands, and we have done the complete analysis of them. Okay, so please do share your feedback. स्टूडेंट इज सेइंग सर Q&A सेशन कब होगा गो क्लासेस के यूट्यूब चैनल पे? ओके, आस्क मी एनीथिंग सेशन. ठीक है, रखते हैं इसको. ओके, आई थिंक दैट आल्सो विल बी इंटरेस्टिंग. सो इन द अपकमिंग डेज, लेट मी कीप आस्क मी एनीथिंग, AMA, that kind of session I will keep. Okay, Q&A, AMA. So these kind of sessions, let's keep, okay, in the upcoming days. So please put a comment if you need any assistance from our side. Okay, from our side, if you have any request, if you want to share your feedback, please put a comment. Okay, please consider our comment section, that we are reading it. Okay, and actually we are reading it. I and Sachin, we read the comments that we get on our YouTube channel. Okay, so please put your comments, please share your feedback. Many times I reply to the comments. Okay, many times. So please put a comment, please share your feedback. Okay, so thank you, everyone.